To tell if lines are perpendicular, parallel, or neither, we have to look at the slopes. And so the key thing is that perpendicular lines have slopes which are called opposite reciprocals, which means that you have to change the sign and flip the fraction. So examples would be 2/3 and -3/2. Those would be opposite reciprocals. We flip the fraction and change the sign. Another example would be 1/3 and -3. Okay, took the reciprocal and changed the sign. So those would be perpendicular. Parallel, the two slopes would be the same. So make sure that when you're doing it, same slope means equivalent fractions. So if you end up with 3/6 and 1/2, those are the same slope. It's the same value, not the same numbers in the fraction. So if the fraction can reduce, you have the same slope and they're parallel. So then the basic idea to answering this question would be find the slopes of these two lines. So let's go through that. Let's do the first line. Let's get it into y equals mx plus b. So subtract 2x from both sides. And then divide by 7. So y equals 2 minus 2/7 x. So the slope of this line is -2/7. And let's do the second line. So this time the y is on the other side. We still want to get y equals, so we'll just work backwards. So 7x plus 14 equals 2y, and divide everything by 2. And so I'm left with y equals 7/2 x plus 7. Okay, and so here the slope is 7/2. All right, I don't worry about the y-intercept. So I'm focused now on a slope of -2/7 and a slope of +7/2. Those two are opposite reciprocals. 7/2 is the reciprocal of 2/7, and the signs are opposite. So negative turns to positive. Therefore, these two lines are perpendicular to each other. This problem kind of goes hand in hand with the problem a couple of slides ago on the sheet where we actually found the x and y intercept. So if you haven't looked at this problem yet, let me just rehash this part. If we know the x-intercept is 6 and the y-intercept is -2, then we are basically looking for the equation of that line. Now there's a couple ways that we can do this. One way is to actually go through and find the equation of the line itself based on all the algebraic process, and we can do that by getting these 2 points. So if the x-intercept is 6, that point is 6, 0. And if the y-intercept is -2, then that point would be 0, -2. And so now I have 2 points, so I can first find the slope and then figure out the rest of the equation of the line. So the slope is, remember, our formula. So y2 minus y1 over x2 minus x1. And so the slope is -2 over -6, or positive 1/3. I'm sure the answers on the final exam are going to be reduced fractions, so that's why I reduced it here from 2/6. Now, normally what we would do is we would set up this equation, y equals 1/3 x plus b, and we'd solve for b, the y-intercept, by plugging in one of these points. But notice part of the problem is given to you that the y-intercept is -2. So I don't have to solve for b, and my answer is simply y equals 1/3 x minus 2. Okay, now the other way to get the slope instead of algebraically would be if you draw the line, you could actually count to find the slope. And here, if you notice, once I have the line drawn out, I go up 2 and to the right 1, 2, 3, 4, 5, 6. So that gives me a slope of 2/6 or 1/3 as well. And then I don't even have to use the slope formula to do that problem. Once I get the equation of the line, a good check is to pull out the calculator and graph the line. And then just note where the intercepts are. So there's the x-intercept of -2 and 1, 2, 3, 4, 5, 6 right there. So that's perfect. If I need to zoom in a little to make sure that it goes through 6, then what I can do is I can choose zoom box, and what I want to do is move the cursor to right around where 6 would be. And then hit enter. So I'll take 5 and 6 into play and see where it crosses. And then what that does is it'll zoom in right into that little rectangle. And so we can see that there was 5 and then that's 6, so that's where it's crossing. To even be more accurate, you can go to the table. So hit second graph and just find the x-intercept of x is 6, y 0, and the y-intercept happens where x is 0, -2, and we're all set. Here's the final slide of the review, and this is on complex numbers. We have 4 separate problems here to simplify. The first, the square root of -28. Anytime you have a square root of a negative number, that's an imaginary number. So the first thing you want to do is you want to take out I, which is -1, or sorry, the square root of -1, and that becomes I times the square root of 28. And now just simplify the square root of 28 like we would have done before. Find the largest perfect square that goes into 28, which is 4, and 4 times 7 is 28. The 4 is going to come out, or at least the square root of 4 is going to come out, and the square root of 7 stays inside. So the only difference here is pulling that I out. The second problem, -5i squared, deals with the property of I, and remember, I is the square root of -1. So I squared, well, what happens when you square a square root? Those values cancel, and we're just left with -1. And just to go down the list, just as a reminder, I cubed then would be negative square roots of -1, and I to the 4th would be sort of I squared squared, so -1 times -1, which would be +1. And then it starts all over again at I to the 5th. Well, in this case, we're only concerned about I squared, which is -1. So -5i squared equals -5 times -1, which just equals 5 is the answer. Here's two complex numbers. This is a FOIL problem, but again, I like to think of these as just multiply everything in the left by everything on the right. And so 3 times 10 is 30. 3 times negative 4i is minus 12i. 2i times 10 plus 20i. And then 2i times minus 4i is negative 8i squared, but just like in the last problem, we know I squared is negative 1, so it's negative 8 times negative 1, which would be plus 8. And now it's just combining like terms. At this point, you can think of I as just a variable. So I have 30 plus 8, which would be 38, and then negative 12i plus 20i plus 8i. And that would be the final answer to that one. Here when I'm adding, be careful when you're looking at these problems that you notice that this is not a FOIL problem. We're just adding or combining like terms. So I just get 3 plus 10. Let me just go down here so I have room, is 13. And 2i minus 4i is negative 2i. And 13 minus 2i is the answer to that problem. If this is the last video you're watching, then I hope after you're done with this that you've got all these things down and you should be ready to ace the final exam. Good luck.